The next question is the increasing order of the following compound towards HCN addition. Dear friends, HCN addition is basically the nucleophilic addition. In this case, it is across the carbonyl carbon. So, basically you have this carbonyl carbon. When HCN is reacting, see, this is how the attack is actually taking place. So, you require this nucleophile Cn minus ion to attack on this carbon, you require a positive charge over there, right. Now, that positive charge is provided most easily where you are having this NO2 group attached, which is showing the minus M effect, right. So, 2 should be showing the highest order of reactivity, okay. Then OCH3 is providing the plus M effect. So, 3 should be at the least position because it is reducing the positive charge on the carbocation. In the first case and in the fourth case, if you see, the groups are at the meta position. So, you cannot talk about the mesomeric effect, but yes, when you talk about the inductive effect, in the case 4 you are having NO2 present, which will help in the attack of the cyanide. And so, I should say first 2 should be reacting, followed by 4, then followed by 1 and then followed by 3. So, let us see the choice if we have. So, 2 followed, so these are the cases where 2 is followed by 4, okay, 2 is followed by 4, and then we are having the choice number 1, then we are having the choice number 3, because in case of 3 we were having the plus M effect. So, the right answer, my dear friends, is choice number 2, okay. Let me just revisit the point once again, that see over here cyanide will attack the fastest because of the presence of NO2, here it will attack the least because of the presence of OCH3, which is showing the plus M effect, okay, fine. Now, let us go to the next question. The metal mainly used in devising photoelectric cells, I would call it as an easy question. The answer is cesium, having the lowest ionization energy, right. Let us go to the next question. Now, these are sort of subjective questions and we need to do a bit of calculation over here. So, dear friends, you have to be really very careful while doing all this calculation. Specifically look at the units, see over here it says in joules. I have just read this, came to me, the first thing that came to me is in joules, which means that somewhere they should be giving it in kilojoules and we have to do the conversion. Okay, let us read the question. The internal energy change in joules when 90 gram of water undergoes complete evaporation at 100 degrees Celsius is. So, H2O liquid is getting converted into H2O gas at 100 degrees Celsius. So, one thing is clear, that delta Ng is equal to 1. Okay, now he is saying enthalpy of evaporation for water at 373 Kelvin is 41 kilojoules. See, they are giving kilojoule, right. I told you some conversion should be there. So, you have to convert that kilojoule into joules. Okay. So, the formula is, you know very well, delta H is equal to delta U plus delta NGRT. Okay. Those of you who are thinking, sir, why did not we take delta H is equal to delta U plus P delta V plus V delta P? We are not taking V delta P because it is happening at a constant pressure. So, delta P is 0. Why we are not using P delta V? Because we are not talking about the change in the volume, and since we are talking about water being formed as a gas, instead of P delta V I can also talk in terms of delta NGRT. Okay. Now, I have to solve it out. There are 5 moles, 41 kilojoules, so it should be 41,000 joules for 1 mole, but we are taking 5 moles. So, this is equal to delta U plus 5 and the value of R is 8.314 multiplied by 373, right. So, dear friends, on solving this you will be getting the value of delta U as 189494 joules, right. So, this is how you have to solve this question. Yes, the calculation is a bit long, but it is only one question out of 25. So, I think you can afford such a long calculation, right. Okay. A simple question, straight formula based, right. Unit conversion is very, very important. So, they want you to be very specific in terms of the units, right. Let us go ahead.